Hello everyone, welcome to this video. Today we're going to learn how to operate your FOTRIC pistol grip camera. So we're going to start by removing one of the batteries from the charging dock. And we're going to place it on the bottom part of the camera. Make sure to go all the way until you hear the click. To remove the battery, you only have to press from the back and the front of the camera to remove and replace for a fresh new battery. Usually when you take the camera out of the box, you will find the SD card already in the camera, but this is how you will replace it. On the left part of the camera, you'll find this area where you'll see the slot to place the SD card. Just make sure to push all the way until you hear a little click. You can seal that back, and the camera should be almost ready to start. Lastly, if you have purchased your camera with multiple lenses, like you have one of these, you will look for the red dot on top of the lens. You will also look for a little dot inside the inner part of the camera. You want to make sure that the camera is turned off. The red dot is going to align with the top part of the cavity. You will find the part where the lens and the cavity align. Then we're going to press and rotate clockwise until we hear that click. Once that is ready, I can open the lens of the camera and I can turn it on. But before we do that, I would like to show you how to replace the hand strap of the camera. For left-hand users, we can take the tool that comes in the box. There will also be a spare part. You can either replace the one here or place the two of them with the replacement one. Take the little screw. And my recommendation is that you place this little slot where the hand strap is going to be located facing upwards. So that's going to look like this. We're going to put the screw. And tighten it up all the way. Now I have a second anchoring point for my hand strap in case the camera is going to be used by right hand or left hand users. All I have to do is to remove this part, untie this other part, and then do the same on the other side. I'm a right hand user, so I'm going to keep it right there where it was. Then I'm gonna pass this through the hole in the bottom. And this part seems simple, is very important. I want to make sure to put the hand all the way through. Oops, I missed this little part, sorry. There you go, sorry about that. So I want to make sure that my hand goes all the way in until my thumb hits here. The knuckles are completely past the hand strap, and I want to tighten it up until it feels snuggle right there. Then I'm going to make sure that this is right here. For additional comfort and safety, you may want to pass the wrist string over here, go right here. And this is going to ensure that the experience with the camera is going to be much comfortable and you can operate easily around the plant. So that being done, we're ready to start the camera. We're going to press the power button for 3 seconds and wait until we see the color bars appear on the screen. As soon as you start the camera, you will hear this frequent click for about the first 10 minutes after the camera has started. It is completely normal. The camera is automatically self-calibrating. You will know that this process is over when you see the symbol going from an undulated equal to a regular flat equal. So let me show you how to get around the camera. First of all, we're going to scroll down from the top of the screen and we will adjust the screen brightness. On this part, we will also be able to turn on the Wi-Fi, the Bluetooth, the flashlight of the camera for dark areas, and the super resolution. The super resolution will create pictures that are sharper with more pixels on every picture that is taken. Bear in mind that these files are usually also heavier for storage. Now, let us talk about focus. In order to get a good thermal picture, it is fundamental to get a good focus of it. So, first of all, the camera comes with an automatic focusing system that is activated by this red trigger button. The camera uses two methods to focus. One is by thermal contrast, and the other one is by using a laser distance ranger. We're going to start with one of them. So first of all, I will click only once the red button, aiming at the object, and wait until those two brackets disappear from the screen. The camera will use the thermal contrast to determine when a picture has been focused properly. If I want to go into further details or focus on specific areas, I can still use the focusing ring on the side. So I can rotate slightly until I get the picture that I desire. As you see here, the picture is out of focus. I can manually adjust until I get the picture focused on the specific object of interest. If I want to use the laser distance focus, I will go to the settings, three dots on the screen, settings over here. I will go to device set, focus, autofocus, and switch from contrast thermal to laser. By using the laser distance ranger, when I click the focus button, the camera will emit a red dot that will measure the distance to a given object. I need to make sure that the object is parallel to the camera and that is not too reflective, so as the light can go back, hit on the object and come back for the camera to measure. There we go, the camera has focused by measuring the distance. If I hold the laser pointer, I'll be able to also measure specific distances of the camera to a given point. So here we see 9.99 feet. And if I want the distance to be saved as part of the measurement of the picture, I go to the main menu, settings, storage and save options, and I will click Save Laser Distance. By doing so, not only when I focus the camera, but when I take a picture with the the black trigger over here, I'll be able to focus the camera first step always, then click the picture taking button, and the distance is saved for me on the screen. In order to save that picture, because right now it's frozen but it's not saved yet, I will click the black trigger button once again and the picture will be saved. Once again, I will change the focus type. Contrast thermal is usually recommended for those environments where there is a good thermal contrast, like say electrical equipment, mechanical equipment, while laser distance is commonly used for, let's say, building inspections where sometimes there are not good thermal contrast that helps the camera focus. In second instance, you want to make sure that you're using the correct temperature range for the camera. You want to ensure that two things happen here, that you use the smallest temperature range possible and also the one that covers the temperature of the objects that you're dealing with. So I can access the menu by tapping the three dots, or I can also do it by hitting or clicking the main center button. I will go to the settings and I will go to the third line, temperature measurement range, and select which one I want to work with. Once again, because the examples that I'm using right now are boiling water and cold water, they're within -4 to 248 Fahrenheit, so that should be good for me. But if I desire to work with higher temperatures, I can simply switch or let the intelligent range do it for me. Those two steps are fundamental. and they cannot be changed after a picture has been taken. So it's very important that you do those two correctly. Lastly, you want to ensure that the distance between the camera and the object is compatible with the type of lens that you're using. In this case, this camera is using a wide-angle lens, and the object is within 3 or 4 feet from my camera, so it's more than okay. But if my object is smaller or it is at a farther distance, I need to make sure that I have a telephoto or ultra telephoto lens for my camera. So once you have the camera in focus, the temperature range is correctly set up, and you're working at the proper distance between the camera and the object, the next step is to adjust the temperature span. For general inspections, you can use the auto temperature span right there. I can once again use this or my fingers to tap on the screen. This will make the camera adjust the top and bottom values of my palette to make sure that I always get good imagery. However, for further controlling the span and level, I will go to the second one, which is manual, and I can adjust by scrolling on the right side of the screen. By doing this, both the top and bottom limits are moving together. If I only want to adjust one of them, I will, let's say I want to use the top one, I will turn off the bottom one, and by scrolling, I will only be adjusting the number on the top. I can do the same on the opposite side and adjust only my bottom limit. So, in other words, I can tap one of them to adjust the span, or I can tap the two of them to adjust the level. Now, I can also use the touch span and level and tap on different areas of the screen to make sure that these two values will adjust based on a reference point. So let's say I'm going to tap on the colder cap, or I'm going to tap on the hotter cap. By this, I ensure that I have a reduced temperature span focused around the temperatures of the object of interest. So once you have decided which temperature span and level you want to use, once again, you can do it here or auto. There is one more way that you can do it. I can tap here, open the settings, device set. I'll go to manual mode, and instead of using these keys to adjust the maximum and minimum temperature, I can adjust the temperature spans symmetrically by using these keys as well. So I'm going to change that. Now once again, if I go to temperature span, manual, you will see that there is a temperature span of only 2 degrees. If I tap right, I will increase that number, and both the upper and lower limit will automatically adjust to fit that specific span. Once again, I'm just increasing that span. I can still adjust the level manually by scrolling on the screen. Okay? Once again, I can increase it, or I can decrease it and make it as small as 2 degrees. I will return to auto to have a better picture over here. I'm going to focus the camera once more. Now, the camera also comes with multiple image modes. To access those image modes, I can go to the third icon on the screen. I have infrared, I have digital, 13 megapixels to get good clear pictures. I have picture-in-picture. So one way to do that, once again, is by accessing the main menu, navigating to the temperature scale or temperature span and level, and use the auto for general scans to identify the object, to later move to manual and then adjust specifically. Or I can set up the AI button to work as a shortcut for me. So all I need to do is to press the button and hold it for 3 seconds. I will go and find this specific feature, switch scale mode, and click on center button. The camera now is ready so that every time I press the button, it will automatically switch from auto to manual, from manual to touch. Usually requires 2 clicks to start after you set it up. So now I'm in touch, click again, I'm in focus, and I'm again in manual. Once again, it's a shortcut to avoid all that step by step. Now I'd like to show you how to set up the camera parameters. The camera parameters include emissivity and some others. To adjust the emissivity of the general scene of the camera, I will click right here and adjust the value based on the material on the surface of the component that I'm working with. There are some suggestions on the right side for quick access, but we always recommend that you use the specific emissivity either from a chart or from experimental testing. I'm going to return to something closer to what we're dealing with. To ensure that the right emissivity is being set up, I will finish by clicking center button. I can also adjust in the parameters the reflected temperature. I will simply scroll until I adjust the specific temperature. I can do the same for ambient temperature, same procedure. Relative humidity on the specific location when I'm doing the inspection. Distance from the camera to the object. Once again, this is for manual input, but if I have set up the camera as I showed earlier to measure the distance, the camera will automatically do it using the laser ranger. And lastly, we have the IR window compensation system. I need to ensure that first it is turned on. I will adjust the temperature of the optics and the transmissivity rate of that IR window. I will click center button, and I know that the camera is being used in the IR window compensation because I can see the icon right on the top left of the screen. I will go back and turn that off. On this camera, I can take advantage of the additional digital camera that is in the front of the device, with 13 megapixels that can add additional details when performing a thermal imaging inspection. In order to access that, I can tap on the main menu, third item, and I will see the different visualization modes. I can do this every time that I want to switch, but I can also set up the AI button to work as a shortcut for me, where I would like that button to switch image modes every time I press it. So I already did it, and all I have to do is come to the point, look in thermal, press on the button again. Now I have blending mode. For blending mode, I can adjust the level of transparency that I want between those two images. I can also have picture in picture. For picture in picture, I can tap in the setter, reposition those, relocate them. I can also adjust the size and shape of it. And lastly, I can go to full digital mode with the 13 megapixels of the camera. I can add additional details, sharp images, not only of the specific components, but also of the surrounding area, which will help locate and understand what's going on around the given components. And now I would like to show you how to use the different measurement tools of the camera. For that, I will go to the fourth icon of the screen. I can use one spot to measure temperature, and now you will see that when I aim the spot at different objects, the temperature will change right in front of the spot's number. The camera can accept multiple spots for me to control multiple components or areas, and I can simply move them and relocate them wherever I need them. I'm going to clean my screen now, go to the trash bin and delete all of them. I can also add boxes. These boxes can be repositioned. They can also be resized and reshaped. I have area 1 and area 2. Now you see there is a lot of information on my screen that I might not want. In order to adjust that, I will go to the ROI sub-menu and then go to the display. I'm not interested in seeing the minimum temperature or the average temperature. I only want to see the maximum and the emissivity. This emissivity refers to the local emissivity of each box, which means that I can have a specific emissivities for specific components within the scene. So let's say I'm going to tap on area 1. Once area 1 is selected, I can tap the menu and I will go to partial or local emissivity. I will turn that on and change the emissivity of that specific component, enter, and you will see how the temperature changes for that specific component. Having two objects on the screen is a common practice for many types of thermography. I can use those two components to do a delta T. To activate a delta T or temperature rise, I will hit the third icon. I will turn it on. And the way you can do that is that you don't have to compare two components, but you can compare multiple components to one, many to one. So in this case, I'm going to use area 1 maximum temperature, but I could also use area 1 minimum temperature or the average. I'm going to use for now area 2 maximum temperature as my reference point, my reference temperature. So now you see that in the top part of the screen, it appears that delta T reference temperature is area 2 maximum temperature, which is 92 Fahrenheit. The difference between that and area 2 is 0 because it's comparing with each other. And the difference between that and area 1 with the low emissivity is 136. What happens if I add additional objects like a few spots and a few boxes? You will see that all these boxes, move this one and make it smaller and move it to the side. So all these boxes are now being compared with the temperature, maximum temperature of area 2. So I don't have to compare 2 by 2 or 2 at a time. I can compare all of them to one single one at a given point. The same can be done with a fixed temperature value. I go to delta T and I will go all the way to the last item on the list, which is temperature rise. For temperature rise, I will set up a specific temperature value, let's say, I don't know, 77. Click enter, very important. Now my reference point is 77 and all the values that I see on the screen refer to the difference between those boxes or spots and 77 degrees Fahrenheit. To clear the screen a little bit, I can do hide the emissivity to have better visualization, or if I want to get a clear picture without eliminating anything on the screen, I will scroll down, hide my objects, I get a clear picture, and I can go back to my analysis without adjusting anything else. I'm going to clear those ones, eliminate all of them at once, but if I have a few ones, let's say, I can simply tap on one of them, click the three buttons, and delete individually. I'm going to locate this one over here. Now you may have noticed that all this time I have the R window compensation. So make sure that you know when you're using it and when you're not. Just turn it off. The camera also allows for other type of components, ROI components. I can also have a circle. This circle, I can readjust the size, position, and do everything else that I did earlier. And I can also add straight lines to measure specific components. Okay? Some users, for instance, like to place those on electrical components for the three phases and measure right away which is the highest temperature on those three instead of having multiple boxes. Every person has different ways of working. Once again, all of them work as measurement tools, so all of them can be adjusted with a specific emissivities. And I can set up temperature alarms for any of them. So let's say I'm going to use the circle. Once the circle has been selected, I can tap on the three dots on the screen and assign a temperature value that will trigger an alarm. I can use a high temperature alarm, compare with the maximum temperature of the box, the circle, and decide which value that's going to be. So I'm going to lower that value to ensure that I have something triggered. Right now it's silent, I can keep it silent. And now you see that the temperature on box 1, let me just turn off the delta T for a second to make it easier to understand. Here we go. So now you see that the maximum temperature on my circle is 89, which is obviously above the threshold temperature. And that's why I see a red value right here. I can also make that temperature alarm have a sound by moving from silent to buzzing. And if I move from high temperature to low temperature, let's say I'm going to adjust that to a very high temperature to make sure that I get the buzzing, I have a different alarm, and then the color will switch to blue. This is a quick way to walk around doing scans and identify temperatures that are out of the standard. So we move and turn that off. And now we'll clear my screen. I would like to show you how to utilize multiple palettes on the screen. I will access the main menu, which can be accessed by tapping the 3 dots on the screen or by clicking the center button. I will navigate to that specific one, palettes, or I can tap on the screen. If you want to know the name of a specific icon, all you have to do is to use the directional keys and locate the specific icon. You'll see the name. So right here I have commonly used palettes, but if I go to these 3 dots over here, you will see the entire library of palettes. So right now I have about 17 different palettes, and I'm going to show you gray. This palette shows hot as white and cold as blue. Instead of having a second palette, what we have done is to give you the ability to invert any of them. So by tapping on the right top corner, now the same palette has turned hot, black, and white for cold, which means that you have a total of 17 times 2 equal 44 different palettes on the camera without the need of going back to your computer to do further analysis. I'm going to stick to one of these, let's say gray-red. And the camera also offers isotherms. In order to access the isotherms, I will tap the palettes and I have above, below, temperature, and then in between. This is a quick way to identify equipment that is overheating or above manufacturer's recommended temperatures. So what I'm seeing is a scale of gray and a number over here. So by tapping that and ensuring the number is blue, I can adjust it with the directional keys. I'm going to lower that value. Right now it's 84. So if I perform a quick inspection, I know that as long as I see gray, there's no issue. But any component that is above the temperature will automatically be highlighted on the screen, making it easier to identify and locate objects that are out of the standard. The same applies for lower temperature. This palette or this isotherm is commonly used to identify potential location of moisture and condensation. All I need to do is to identify what is the dew point in the specific room where I'm doing the inspection and locate that or put that number in here. So let's say that the dew point of this room, which can be calculated using a hygrometer, is 69.8. I can run a quick inspection in my room, and as soon as I see blue, I know that on the surface where I'm seeing blue, is very likely that condensation is accumulating, and further later on, moisture will be accumulated because of moisture condensation. So this is also by some users known as dew point identifier. And lastly, we have the ability to show color only for in-between temperatures. So I'm gonna bring this maybe a little higher. Blue means that I'm working with it. Let me just adjust to a value that works for us. There you go. So right now my camera is between 39 and 80. That is, which means that the second cap is between those values. Nothing below 30 will show, nothing above, nothing below 39, nothing above 80 will show on the screen. So that's how we use isotherms on FOTRIC cameras. Back to a regular palette, and then I can continue. All the different items and actions that I have performed can be set up using the AI button. Once again, you press and hold, and you will find the specific feature that you want to place a shortcut on. For instance, I can do palettes preview if that is something that I commonly do. And simply by tapping, remember twice the first time, it will show me the specific configuration of palettes, all the different options. Just by tapping, just by clicking in one button. So now that we have understood how to use every part of the main interface, I'll show you how to take pictures, how to capture, how to edit, and how to add additional comments on those pictures. So first of all, remember the most important thing when you're taking a picture is to ensure that you have a good focus, whether you use the manual focusing ring or you use the autofocus. I focus on my objects. Next step is to press the black button or the black trigger. Only clicking once, I don't need to hold it. The camera will measure the distance if that's what I'm doing, asking the camera to do. And the image is frozen, but it hasn't been saved. This is so that I don't have to hold the camera in front of the object while I'm doing edits before I save the picture. Now I can lower it, I can move away from a hot location, and I can edit things like I can adjust the temperature scale or span and level, as we learned earlier. I can also create additional ROIs or regions of interest. I can locate those, place them right here. And you will see something interesting now that I have just created a box. Because the camera is being set up to measure the distance between the camera and the object, and is measuring about 4 feet, the camera is doing a calculation of the area of this box projected onto a given surface. The size of the box on the screen combined with the distance will give an estimate in square feet of the area of this box. Now, this is particularly useful when we're doing building inspections. It probably wouldn't apply here with the 2 cups that I'm using as reference, but if I'm measuring the area of missing insulation, for instance, it's a good way to determine how much materials will be needed to fix a given missing insulation component, just to give an example among many. I can also, in this frozen interface, I can go to voice recording, tap on the recording button. I want to record a comment on my findings today. Finish, and then I can listen to it. The camera will use the speakers that are over here to play that audio. Probably you wouldn't hear because my microphone for this video is not close enough. The camera will also play that if I have connected Bluetooth earphones to it. I'll show you later how to do that. So once my voice has been recorded, you will see that icon on the top left, which can be later been listened on the gallery or in the computer software. I can also add text, comments. I can use QR codes. The QR code or the scanner in general will scan either QR codes or barcodes to capture text that will go right here. In addition to voice annotations, I can also create text annotations. Those text annotations can have comments that I can type directly on the keyboard on the screen, Or I can capture text from QR codes that are present on the assets. I will open the QR code, direct to a specific tag, and then I see the content of that QR code already captured on the camera. If I confirm the reading, that text will be included in the text annotation as part of the information of the image. I can also use this tool to capture information on barcodes. So if I scan the QR code and address a barcode, the information, which is generally numbers for barcodes, will also appear there, and I will capture that as a text annotation. Lastly, I can also use the OCR feature. For the OCR feature, I need the camera to be connected to the internet. I tap here, I open the scanner as well, and I will aim at a given text. For this feature, I can even adjust the size of the area where I want the camera to read. And then I click the picture taking button. It will take a couple seconds. The camera will capture that text telling me I'm in the mechanical room 12, panel 05, and that's what I want to add as my text annotation. 3 different ways to add annotations on my camera. I will go and save. Now I see an icon telling me that there is a comment or annotation on the image. But most interesting is to use tags to also organize my pictures. Once again, I can have the same 3 methods. Let's say OCR. In the case that my panel, my equipment, my motor hasn't been properly tagged with a barcode or a QR code, I can always use OCR with a good Wi-Fi connection. Once again, I can adjust the size of the area, take a picture, the camera will identify the text, I will confirm and save it. The reason to use tags over comments is that once the picture is saved, for that I will have to finish my edits and then save the picture. I can go now to the gallery, press gallery button, and I can filter all the images on my camera. You can see that there are quite plenty of them, and filter them by tapping the funnel, finding the tag, which is mechanical room 12, panel 05, confirm, and see only those pictures that have been taken for that specific asset. Every time that I come back to the same asset, I'll be able to do the same and find pictures specific to a given asset. If I delete that and confirm, I'll do that again. So once again, the process is very simple. I focus, I freeze the image. If laser ranging is in progress, it will take specific measurement. Now we see 10 because it's measuring all the way the corner of my room. And then I can add specific comments over here. If I find that adding tags or adding voice notes is a common practice for me, instead of doing the step-by-step over here, I can also set up my shortcut button to do that for me. Press and hold for 3 seconds. Let's say QR code tag, enter. Once again, press twice, and then the camera should be ready, which means that I'm going to do it again. Freeze the picture, press the AI button, and the camera will automatically open my QR code, my OCR. There are other features that you can explore on your own, which can be set up to automatically appear when you press that button. Lastly, favorite is one way to mark pictures for multiple reasons. It can be, for instance, mark something with an anomaly. In those cases, I can press the AI button after the picture is taken, and the favorite icon will automatically appear in the corner. Now I'm ready to save the picture by pressing the black trigger. And if I go to the gallery once again, I might have hundreds of pictures. But I can find the favorite ones, which can mean, for instance, pictures with anomalies or that require further investigation. By simply tapping, I will see those pictures that were previously marked. All right, so with this part we finished how to capture and save images on this camera. Now we'll show you some additional features. Going back to the storage and save options, you may have noticed that in video format there are two formats: IRS, FOTRIC radiometric video recording file, or MP4. IRS will contain all the temperature data on a video, while MP4 will simply record a non-radiometric video. If I keep it on IRS and I go to capture mode, switch from single frame to recording, I can choose the frequency or frame rate of that video. On the camera can process up to 16 Hz. When connected to the computer, can go all the way to the 30 Hz the sensor has. Now you will see this new icon on top. I will press the trigger button once, start recording. You will see the counter on top indicating how many seconds have passed so far. And then I'll click once again to save that video. But remember, when I do that, the image or video is frozen, yet it's not saved. On this part, I can also add voice notes. I can create annotations. I can also add specific measurement points or boxes. So this video is completely radiometric. I can capture temperature data anywhere on that video. Let's say I'm going to move this spot over here. And then I'm going to press the picture taking button once again. The camera is going to save it. If I go to the gallery, you will see a video right there. Tap in again. I can open the video, replay, but not only that, I can relocate any of the measurement objects. I can also change the palette of that video. So this is a video that I can completely customize and edit on the camera without the need of going back to the computer. Try a non-radiometric video. I'll go to the settings section, storage and save options, video format, MP4. On capture mode, I don't have to choose the frame rate because it's going to have the full 30 Hz on this mode. Start recording. Again, I'll take a couple seconds. Take it again. It doesn't give me a frozen interface to modify because I cannot. It is not a radiometric video. If I go to the gallery, it's just a standard video. That is easier to share, it's probably lower in size, but of course wants to give me the opportunity to do adjustments in the post-processing stage. Lastly, on capture mode, I can switch to time-lapse. Time-lapse will take pictures in the frequency that I set up the camera for. So let's say I want the camera to take a picture every few seconds, let's say every 2 seconds. And I want the camera, for the sake of this video, just keep it short, I want the camera to take 4 frames. I hit enter. And this is very useful when I want to record temperature processes that take long periods of time. A common complement on this feature is the use of the tripod adapter. I can mount the camera on a tripod using this adapter, aim the camera at a given process that can take from minutes to hours, and start the recording. Now I see that there are 0 out of 4 frames taken. I will click the picture taking button. It takes the first one, it waits for 2 seconds to take the second, 2 seconds, the third one, 2 more seconds, the fourth one. When it has completed, it tells me the results. I'll confirm, and if I go see those on the gallery, they have a different icon indicating that 4 pictures were taken together in one go. I can set this up to do it in a longer period of time, longer intervals. Like I want the camera to take a picture every 1 minute or every hour, every 60 minutes, and tell the camera to take more frames, like 1,000 frames, or just stop when you hit the button. So this is a very useful feature, once again, when you want to control the heating process of, let's say, a machine from cold and neutral all the way to operating temperature. I'm going to go back to single frame now. Now I would like to show you how to connect the camera to the Wi-Fi or Bluetooth. I will go to the connections interface, open the Wi-Fi connections, and just like you do on your laptop or your smartphone, you can search or refresh the networks the camera has access to, tap on any of them, and the camera will ask you whether you want to connect or not for you to type in a password, and the same procedure that you will use in any mobile device. For Bluetooth, it's a similar operation. You just need to turn it on, find the headset so that you can listen to those alarms that I mentioned earlier, so that you can also record voice notes using a headset or earphones. And this is going to be the device name if you're searching from an external device. The camera also comes with a hotspot, meaning that you can connect mobile devices to the camera, and even though the camera does not have internet, it can create a Wi-Fi connection. So I can turn that on and use my laptop or my smartphone to find FOTRIC network, use the password that I have typed right there, and connect my mobile device directly to the camera. This is particularly useful when I'm using IR Explorer. For this, we're going to have a dedicated video explaining all the benefits of it. So you can go and find how to use IR Explorer or similar videos for this specific feature. Lastly, I would like to go with you over some of additional device characteristics and settings. On the language and date and region, pretty much we can adjust date, units, language that I'm using. So I just explained how to use the temperature scale using auto and manual, and how this can help to eliminate areas of temperature that I'm not interested in seeing on the screen. But there is a special feature for that as well. I can go to the main settings, go to device set, and then have TWB activated or not. Let me show you what it looks like when this feature is turned off first. Imagine that you are in an environment where high temperature components are present in the back of your scene. Let's say you're in a refinery, or you are in the presence of boilers or flares. So if I bring a hot object onto the scene, it will automatically make the camera shift the values of the temperature span all the way up to make sure that there is a color to cover that area. This is because the camera is using a linear function to equalize the colors. After that object leaves the scene, then I'm able to see the details. But in presence of high temperature objects on my camera, I will completely miss what I'm really interested in, which in this case are the two objects on the screen. Now, if I go to the settings, device set, TWB, now that the feature is on, I can see the two objects on the screen, and even when a higher object appears on the screen, the camera will equalize everything to make sure that even both the high temperature object and the objects of interest still remain with colors that can give me information about the temperature distribution. Now, you have noticed that every time that I capture a picture with this camera, it's going to measure the distance, and it's going to show it right here. Now, what if I want to know what's the actual distance that the camera is using to do calculations? I'm going to cancel this for a moment. I will go to the settings. I will go to storage, first we're going to go to device set, display, image overlay, and I can show a number of information that is going to appear on the screen. In this case, I want to show distance. But let's do a few more of the parameters that can be adjusted on the camera, just for an example. So now I have in this bottom corner all those parameters, including the distance. Now when I take a picture, the camera will measure that distance, and it will automatically save this distance into that parameter of the picture. So when I save the image, that information is going to be saved, and now the camera is going back to the actual distance that I had manually put in it. Now, as I mentioned earlier, for many applications, distance measurement is not necessary. So I can go to storage and save options and turn off the laser distance saving on device. One of the other things that you have seen is that every time I take a picture, there's a thermal and digital picture. I do that by activating the seven digital images separate. So if I were to turn that off, I just deactivated those two features. What happens now is that when I take a picture, it automatically saves it. It doesn't have to measure distance anymore. And if I save the image by clicking the second time on the trigger, now you see that I go to the gallery and only one thermal picture was taken. While previously, both the thermal and the digital were taken at the same time. One of the advantages of having a good digital camera is that whenever I open one of these images on the gallery for post-processing on device, now I would like to show you a few last features on the camera settings. If we go to device set, on the first row I can adjust the language of the camera, the different units for temperature and distance, and how the camera is going to present date, time, and format for the date as well. The IR Edge feature is a feature that is already on board, and it's an algorithm that will ensure that the camera presents sharp objects or objects with sharp edges along distances in a sharper and more clear way. It's currently activated by default. If I go to the display mode, I can adjust the screen display brightness, but I can also do it from here, just scrolling down and adjusting just by sliding on the screen. So going back to device set, display, image overlay, as explained earlier, it will show me what data is going to be shown on the screen during the inspection. And the last row, it will indicate the level of transparency when I'm doing blending, which is right here, the fourth mode. Lastly, I can turn on the location of the camera. In order to use the GPS, the camera needs to be outdoors for a couple of minutes, after which you will see the coordinates of the camera on this area, and you'll be able to save that information every time you take a picture. The LED lamp as a flash will make the camera turn on the flashlight every time you take a thermal picture. This is particularly useful if you're doing inspections in machine rooms or environments with very low light, so that the digital picture comes with good resolution. So if you see here, I'm going to take one picture, the flash is activated, it illuminates my hand, and if I save that image, we will see, well, I need to turn on the digital camera additional picture. So save digital image as separate. Do that once again. You see the flash illuminating my hand. Picture is saved. And then if I go to that picture, I can get a better illuminated picture, especially when you're doing electrical panels or when you're doing machinery that is in hard to reach areas. The camera will help so that you get good pictures for your maintenance team. The screen off feature helps the camera save battery by turning off the screen. You have to be careful on how this is used. If it says the 5 minutes, it means that the screen alone will turn off, but the camera will remain on. This is to ensure that the camera keeps its internal temperature and the temperature readings remain stable. The camera will do something like this. The screen will go off, but the device itself is still running. So whether you do it by automatically letting the screen go off or manually doing it, all we have to do is to press the button once instead of holding it to turn the camera on completely. That's another interesting thing to know. Once again, if I press the button once, it will go off, and if I press it once again, the screen will turn on again. We discussed all these features already. The last thing that I would like to show you is how to update your camera. FOTRIC constantly releases new software versions that improve performance, fix potential bugs, and bring new features onto the cameras. So there are specific instructions on how to do that, but real quick, we're gonna go to About. We will go find the last row, which says System Update. And in Software Update, we're gonna tap and let the camera search for updates. Once the camera finds it, we just hit an upgrade and the camera will do it. Remember that in order to do this, we need to load the update file onto the camera SD card. Let us explore some of the buttons that we haven't tried much yet. The first one is the laser pointer. The laser pointer will turn on a laser that works as an indicator for me to show and discuss with people that are going around with me. But it also serves as a distance measurement device. So I can aim at a given component and the camera will measure the distance and show it on the screen for me. It's not saving it unless I activate that on the camera. It's simply telling me what's the distance between the camera and the component. The other one is the gallery button. We know that by pressing the gallery button, it will take me there. But if I also press and hold the gallery button, the camera will activate the NUC calibration. This is particularly useful when the camera has been idle, aiming at one single component, and some ghost images can appear on the screen. It will take just one or a few of these operations to make sure that the camera is uniform in its entire screen. Let's finish by looking into the gallery. I'm going to choose one of the images that we took previously. To analyze it, I can either tap on the Analyze button or simply tap twice on it. The image is loaded, and then I can do any sort of editing like we did during the inspection time, because the camera allows for complete analysis and post-editing on every picture on device. I can, for instance, change the palette that I'm using. I can add additional measurement objects. I can also create delta T's between them. Let's say between spot 1 and area 1. Enter. We see that over there. And then to save the image, I will hit the back button, confirm that I want to save those changes, and I'm ready to go. Once again, everything is stored in the memory, the SD card on the side, which I can access by either connecting the camera to the computer via USB, using the port on the side, or by removing the SD card and reading it using SD card reader. For the last part, I would like to show you how to connect the camera to different interfaces. So when we open this area of the camera, we will see the first interface, which corresponds to the HDMI cable. This is a mini or micro HDMI that, by being plugged over here, allows me to export live streaming to a screen or to a projector. We also have a USB-C connection, which allows me to connect the camera and live stream with radiometric data to one of our computer softwares, to access the gallery using USB 3, which is a high-speed transmission data interface. And lastly, we have the power interface that allows the camera to be connected directly to the power if I require to do inspections for long periods of time. If the battery is plugged onto the camera, this power source will also charge the battery internally. Alright, I hope that this video was useful for you, and remember, if you have more questions, you can also refer to the written user manual or contact us at info@fotric.com.